Hi, welcome to my YouTube channel Vaishnav360. Like, share, subscribe, and do not forget to hit the bell icon.
Hello guys, welcome to Vaishnav 360. Today we are going to do Roman number 2 in exercise 1C. Okay, we are going to do the first problem, that is find the domains of the following real valued functions. There are three, I think so, 7 to 8 bits. Now we are going to do those. Firstly, I will write only the bits first and then start. I will not write whole bits, it's a time waste. No. Okay, now the first bit is f of x is equals to under root x square minus 3x plus 2, which belongs to real numbers. So here we will take x square minus 3x plus 2 is greater than equals to 0. I have told you, every time we should take only the terms which are there. We should not take under root because real numbers does not have roots. Mostly there are roots for real numbers for few, but if there is like algebraic type, we will not use roots for them. Okay, now we will take x minus alpha and x minus beta is not equals to, is greater than equals to 0, then x smaller than equals to alpha or x greater than equals to beta. This is the formula. Okay, now x is smaller than equals to 1 or x is greater than equals to 2. Now we can write minus infinity till 1 and which is union with 2 to infinity, because this is 2, no, there is no end for the numbers, so it is from 2 to infinity. From 1, if we take the integers from the left side also, we can write minus infinity. That's why we have took this. Now we can write, therefore domain of f is minus infinity comma 1 united with 2 comma infinity. Okay, you must be thinking, how did I get uh, like how did I divide this quadratic equation? Now I will show it. Wait, I have done it already in the separately calculation, so I have directly by mistake I did not mention it. Now see, x square minus 3x plus 2, no, now we will take, we will multiply these two, 2x square, then minus 2x minus 1x. We can write like this. Now if we multiply, or if we multiply, we will get this answer, right? If we add, we will get this answer. So this is the perfect one to which match the equation. So it is x square minus x minus 2x plus 2 is equals to 0. Now x of x minus 1, okay, minus 2 of x minus 1. Sorry for the congested way of writing. No, I am explaining, no, you may hear and note it down. Now lastly we will get x minus 2 and x minus 1, which is no, equals to 0. Now we will divide it, x minus 2 is equals to 0 and the second one x minus 1 is equals to 0. Now we will get x is equals to 2 and x is equals to 1. Now I have, from here we can write like this. Okay, now we will get this answer because there is greater than symbol here. We will continue writing greater than and less than equals to symbols here, and we will continue like this solution, and we will get this answer. Okay, now we will do the second bit in the first question. Okay, now we are with the second question, that is f of x is equals to log of x square minus 4x plus 3, which belongs to real numbers. So here we can write, we have directly this three terms, we will write it directly and write greater than 0. Now this is an quadratic equation, we should solve this. Let us solve this. We will take 3x square because we will multiply these both, no, then we will divide it by minus 3x minus 1x. Okay, now it is x square minus 4x plus 3 is equals to 0. Now we will add these two here. We will separate this one and add this two. Okay. Now x square minus 3x. Okay. X square. Wait a second. Let's write 1x here. X square minus 1x minus 3x plus 3 is equals to 0. Okay. Now we will write x of x minus 1 and minus 3 of x minus 1 is equals to 0. Now x minus 3 of x minus 1 is equals to 0, right? This is the answer for the above. Now we will write here. Wait. X minus 3 is equals to 0, x minus 1 is equals to 0, and x is equals to 3, x is equals to 1. Now we will write here x is greater than equals to 1, or x is smaller than, x is smaller than equals to 1, or x is greater than is equals no, greater than 3. Okay, this is the answer. Sorry for the disturbance. So here you can see. Okay, now here we took these two. Now we will know what x belongs to. Now x belongs to minus infinity till 1. Okay, then union 3 to infinity. This is the first one, so it will go from the left side, from here to the left side, and this is the greater one, so this will go from the left side to right side. So from here to infinity, from here to infinity, this is minus infinity, this is normal plus infinity. Okay, positive, this is positive and this is negative, so it is minus infinity, positive infinity. Okay, negative and positive. Now therefore we can write domain of f is minus infinity comma 1, which is union with 3 comma infinity. This is the answer. Okay, now we will do the next question, that is third one. Okay, sorry, third bit. Okay, now here we have the third bit, that is f of x is equals to under root 2 plus x plus under root 2 minus x by 3. Okay, now we will take all the terms. Okay, x is not equals to 0, and the next term, that is 2 plus x, we will not take root. Okay, is greater than equals to 0, and the this term. Okay, 2 minus x is greater than equals to 0. Now we will simplify this by x greater than equals to minus 2. Okay, now x minus 2 smaller than equals to 0, and here we will get x is smaller than equals to 2. Now here we will write united. Okay, now here x belongs to, not x belongs to, because we will write the because here there is x, that is a term, so we will write the pair, that is minus 2. We can call this as a set, but I am calling as a pair because it is very simple to recall. Okay, minus 2 is smaller than equals to x, and x is smaller than equals to 2. Then we should minus 0, that is we should eliminate or deduct 0, because x is not equals to 0 here, so we should deduct 0. Now this is the answer. We will write therefore statement, that is domain of f is minus 2 comma 2 minus 0, that is eliminating 0. Okay, this is the third bit. Okay, this is the answer for the third bit. Now we are going to the fourth bit, that is, now here we are with the fourth bit, that is f of x is equals to 1 by 3, that is cube root x minus 2 into log with the power 10 base 4 minus x. Okay, now we will solve this question. x minus 2 is not equals to 0 because it is in the cubed root, and 4 minus x is greater than 0 as usual in every problem. Now 4 minus x is not equals to 1. Uh, this is not equals to 1 because if uh, if 4 minus x would be 1, the above letter, the above here, it would be 1 as the answer. It would not come, it would not be down the denominator or anything. Okay. Yeah, then x is not equals to 0. X minus 2, no, wait, it will come here 2 and 0 will not be there. Then x is not equals to 2, and again x minus 4 is smaller than 0, and x here will come, x is smaller than 4, and here we will get minus x is not equals to 1 minus 4, and minus x is not equals to minus 3. Okay, I think you may all see clearly, and here minus minus get cancelled. X is not equals to 3. Okay, now we can write here x belongs to minus infinity comma 4 minus 2 comma 3. Okay, this is the answer. Therefore we can write domain of f is minus infinity comma 4, and we should deduct 2 comma 3. That's why we'll put a symbol of minus. So this is the answer for the fourth bit. Now we are going to do the fifth bit, that is 4 minus x square by x plus 2. Okay, this belongs to real numbers. Okay, now we will solve this question. That is, we will do two cases in it, because there is uh, the denominator we have 1 and we have the numerator. Okay, we have x in both, so we will take case 1 and case 2. First, in case 1 we will do, case 1 we will do 4 minus x square, okay, greater than equals to 0, and x greater than minus 2. Okay, we will divide it. Yeah, we can write x belongs to minus 1 to infinity, because x is smaller than, x is greater than minus 2. So minus 2, if there are numbers in, what do we say, greater than minus 2 or minus 1 to infinity, that is positive. Okay, only minus 1 is remaining, that is greater than minus 2. So we can write minus 1 to positive infinity. Okay, now we will solve this equation. Okay, we can take 4 as 2 square minus x square greater than 0. Now we can write 2 plus x, or 2 minus x of, sorry, because of the formula which we used, that is a square minus b square formula. So we have got this answer. Now 2 plus x greater than equals to 0, and 2 minus x greater than equals to 0. Okay, now we will get here, now we will get x greater than, sorry, x smaller than equals to 2, and here we will get x greater than equals to minus 2. Okay, okay, okay. Now we can write here, that is minus 2 is smaller than equals to x, and x is smaller than equals to 2. Okay, and here x belongs to uh, minus 1 comma infinity. Now therefore we will write the first equation, that is x belongs to minus 1 to 2. Okay, this is the first equation what we get. Now we'll go for case 2. Here we will write case 2. Okay, case 2. In case 2 we will again write 4 minus x square, which is smaller than equals to 0, and x plus 2, which is smaller than 0. Okay, now we will solve this. First I will solve the second one. We will get x smaller than minus 2 and x, here there are brackets now, so I will write brackets smaller than minus 2. So x belongs to minus infinity to minus 2. Okay, now here we will get, we can write 2 square, same formula will apply here also. Minus x square under root under root I told. This is smaller than equals to 0. Now we will get 2 plus x, 2 plus x of 2 minus x, which is smaller than 0. Then we will get 2 plus x smaller than equals to 0, and again 2 minus x smaller than equals to 0. Now here we will get x is smaller than equals to minus 2, and x minus 2 is greater than equals to 0, and x is greater than equals to 2. This is the answer what we will get. Okay, now we will get the second equation, that is uh, x belongs to minus infinity comma minus 2. This is the second equation. Now we will write from equation 1 to 2, that is from equation 1 and 2 we will write here. From equation 1 and 2 we will get x belongs to minus infinity comma minus 2 united with minus 1 comma 2. Um, this is the equation which gets combined and form this answer. Okay, now we are going to do the sixth bit, that is that is f of x is equals to under root log 0.3 of x minus x square. Okay, this is the question. Now this belongs to real numbers, no? So we'll take two things, that is log, here log 0.5 and x minus x square, and we'll take another one, that is x minus x square. Okay, we'll write here. Yeah, now we will solve the problem. Now we'll take log 0.3 of x minus x square, which is greater than equals to 0, and here we'll take x minus x square greater than 0. Now x square minus x is smaller than 0, and x of x minus 1 is smaller than 0. Now x minus 0 of x x minus 0 of x minus 1 is smaller than 0. Now we will get, you will think how did I got x minus 0? No, what is 1 minus 0? 1 only, no. 2 minus 0? 2. Same here. X minus 0 is x. So I have written x in form of this. So we can form an equation, that is x minus alpha x minus beta is less than or small than 0. This is the formula. Now we will get the answer, that is x belongs to 0, 0 comma 1. That is the formula. This is the formula, and Using this formula, we'll get the answer x belongs to 0 comma 1. That is, x belongs to alpha comma beta. Okay. Now here we'll solve this one. We'll get x minus x square smaller than equals to 0.3 whole to the power 0. What is a to the power 0? 1. Then what is 0.3 to the power 0? 1 only, no. So x minus x square is smaller than equals to 1. Now minus x square plus x minus 1 is smaller than equals to or lesser than equals to 0. X square minus x plus 1 greater than equals to 0. I have changed the symbol. Here the smaller than changes to greater than. Okay. Therefore, x belongs to R, that is real numbers. X belongs to R and x belongs to 0 comma 1. This is the answer for the above part and this is the answer for this above part. Okay. Now here we got these both as an answer and we'll write x belongs to R intersection x belongs to 0 comma 1. Now here domain of f is 0 comma 1. Okay, this is the answer for the sixth bit. Now we are going to do the next one, that is seventh one. Okay, what is seventh one? Seventh one is nothing but f of x is equals to 1 by x plus what we say modulus x. Okay, I will repeat it, 1 by x plus modulus x. Okay, now here we will take x plus modulus x is not equals to 0. Therefore x belongs to 0 comma infinity and therefore domain of f is 0 comma infinity, because if this would be 0, this answer would be undefined. So it is not equals to 0. Now we will take here 0 to infinity, because we should not count 0 here. If we write 1, they would not count in the answer. In the result we will not what we say verify with 1. We will directly get to 2 if we write here 1. So here I have written 0 so that 1 can also be verified from 1 to infinity but not 0. Okay, now this is the answer for the seventh bit. Now let's go forward for the second question, that is, here we are with the second problem, that is, prove that the real valued function f of x is equals to x by e to the power x minus 1 plus x by 2 plus 1 is an even function on R with 0. Okay, now we should prove that it is an even function, that f of x is an even function on real number 0. Okay, now we are going to solve this problem. First of all, wait a second, I'll hold the page properly so that you cannot means fly or fall down. Now let f of x is equals to x by e to the power of x minus 1 plus x by 2 plus 1 belongs to R. Now e to the power x minus 1 is not equals to 0. So e to the power x is not equals to 1. E to the power x is not equals to e to the power 0. Now bases get cancelled. Now we'll get x is not equals to 0. This is what we'll get first. Next we will get, yeah, now next we will get f minus x. F of minus x is equals to minus x by e to the power of minus x, okay, minus 1 plus minus x by 2 plus 1. Now here we will get minus x by 1 by e to the power of x minus 1, because I have taken out minus, and I will get 1 upon e to the power x, because I have taken minus here, minus x by 2 plus 1. Now here we will get minus x by 1 minus e to the power x by e to the power x. Wait, yeah, now I think you may say e to the power x. Then here x by 2 plus 1. Okay, now here we will multiply. I will write above, multiply with negative symbol, that is minus. Now we'll multiply it, minus of minus x into e to the power of x by 1 minus e to the power of x minus x by 2 plus 1. Here it implies that x into e to the power of x by e to the power of x minus 1 minus x by 2 plus 1. I hope you are all understanding this, because it is a very simple, what we say, algebraic solution. We can easily solve this all, because you would have studied this in 10th and ninth classes. Okay, now x into e to the power of x minus 1 plus 1 by e to the power of x minus 1 minus x by 2 plus 1. Okay, now here I will get x of e to the power of x minus 1 by e to the power of x minus 1 here again plus x by e to the power of x minus 1, and here I will get minus x by 2 plus 1. Okay, here this and this will get cancelled. Okay, okay, now we will get, wait a second now. Okay, uh, here we have got this, no, yeah, we will write here, a to the power of minus 1 is equals to 1 by a. Okay, this is the, okay, here you might think why I was writing a to the power minus 1 is equals to 1 by a formula, because there is nothing here to convert from here to here. I thought of writing this because few members or students who do not know this formula may learn it, and I will show you where I used this one. I used this one here, here, here it was, wait, here I used it. Here it was e to the power of minus x, and next step it will be 1 by e to the power of x. Here I will show you. See, a to the power of minus 1 is equals to 1 by a. Okay. Now we are going to do the continuation here. That is, we will get here x plus x by e to power x minus 1 to the power x minus 1 minus x by 2 plus 1. Okay. Now here I will write here, place is not sufficient. Yeah, here we'll get x by e to the power of x minus 1 plus x by 2 plus 1 And what is this? This is the answer. Okay, done. But what is this? This is nothing but the same f of x. Okay, f of x. Okay. Now here we will write the statement, that is f of minus x is equals to f of x. Here therefore it is an even function. Okay, therefore we'll write the domain of f is real numbers without 0. That means only 0 is eliminated or deducted in the whole set of real numbers. This is the answer for the second problem. Now we are going to the third problem, that is, now we are with the third question, that is find the domain and the range of the following functions. Okay, now the first bit we are going to solve, that is first bit. Okay, f of x is equals to tan pi of x by 1 plus sin pi of x plus x square. Now we are going to solve this one. Okay, now given here is x is an integer, because if there is any term which is in square brackets, then we can represent it as an integer, but this integer belongs to a real number, and tan pi of x and sin pi of x is 0 for all x belongs to integer. Here we can say that if there is a real value, in real valued uh, functions, sine and tan will be always be 0, will always be 0. Okay, I think you understand. I will tell you again. If there is x belongs to real valued number functions, then tan sine will always be 0 for all, that is for all x which belongs to real numbers. Okay, now therefore we can write domain of f is R, that is real numbers, and range of f is 0. Because tan and sine here is 0, we can write totally it is an 0. This is the answer for the third question first bit. Now we are going to solve the second bit. Going to solve the second bit, that is f of x is equals to x by 2 minus 3 to the power, sorry, 3 into x. Okay, x by 2 minus 3 into x, which belongs to real numbers. So here we will take 2 minus x, 2 minus x into 3. So we will write 3 into x. No, wait, 2 minus 3x is not equals to 0, and 3x minus 2 is not equals to 0. We can write any type, right, like this or like this. Now 2x is not equals to 2, and x is equals to 2 by 3, means not equals to, sorry. Now here we will find what is y. Y is equals to f of x, that is x by 2 minus 3 into x, that is 3x. Now here y is equals to x by 2 minus 3x. Now we will get 2y minus 3xy is equals to x. 2y minus 3x. uh, Here we can write, wait a second, here, yeah, 2y is equals to x plus 3xy, and 2y is equals to x of 1 plus 3y, and here x is equals to 2y by 1 plus 3y. Here we can write, wait a second, yeah, 1 plus 3y is not equals to 0. 3y is equals to minus 1, and here we'll get y, that is minus 1 by 3. This is the answer for the y. Okay, from here I have taken x and here I have substituted, and now I got the y, that is minus 1 by 3. Okay, finding x is easier than y, no? This is long but x is short. Okay, this is the answer for the second bit. Now we'll write the statement, that is domain of f is r minus, that is deduction of 2 by 3. We'll deduct 2 by 3, and range of f is r, which is deducted by minus 1 by 3. Okay, this is the answer for the second. Now this is the answer for the second bit. Now we'll go to the third bit. Okay, that is, the third bit is f of x is equals to modulus x plus modulus 1 plus x. That is, now the domain here, we can write it as domain of f is r, that is real numbers. So f of 0 is equals to, we are taking examples from 0 to, those are real numbers, no, that's why 0 plus 1 plus 0 is equals to 0 plus 1, that is 1. F of 2 is equals to 2 plus 1 plus 2 plus 2 plus 3 is equals to 5. Now here we can write, therefore range of f, that is real numbers, is 1 comma infinity, because it is from 1, 5, then etc till infinity, no, that's why the range here is 1 comma infinity. Now we have completed. In the next video we are going to start the lesson known as mathematical inductions. Thank you for watching.